Okay, so this is example problem 102, which is right here. And it says a weak acid HX is dissolved in water, and I wrote it right here. And since it's an acid, it's going to give away its protons, so you end up with X minus and some H3O plus. And it tells you that the pH of a 0.25 molar solution is 4.5. Calculate the final concentration of H plus, right here, OH minus, and the Ka. So they give us a huge hint here because they give us the pH. And the pH is always found at equilibrium. And so that helps us fill in this blank right here, this blank right here, and this blank right here. And so I can use the pH right here to help me find H3O plus, because I can go from pH to H3O plus on the pH square by doing 10 to the negative pH. So use pH 4.5 to find this from the pH square. So I did that, 10 to the negative 4.5. That gives me my H plus ion concentration as 3.16 times 10 to the negative fifth. And so that answers the first question right here, what is the H plus? That is also my X minus, because whatever this is, it has to be the same. And then that's what's gained over here as well. So 3.16 times 10 to the negative fifth is gained over here. I rewrote the ice table down here, and it's also gained over here. And then that's what's lost over here as well, 0.25 minus that. So the pH gave us a huge help to fill in all the numbers on the ice table. And then I have to do the subtraction, and 0.25 minus 3 times 10 to the negative fifth is going to be so close to 0.25 that I just left it as 0.25. So these are the final equilibrium concentrations of H3O plus and X minus. And now I can use these to find my Ka, because the Ka is equal to these two things multiplied together divided by my final, or my equilibrium concentration of Hx right here. And so I did 3.16 times 10 to the negative fifth squared divided by 0.25. And it's not being 4 times 10 to the negative ninth. That would be my Ka for this acid. Now I didn't find the OH minus ion concentration, but I'd have to use the pH squared to do that. And the pH squared would help me take whatever my H3O plus is, which is right here, multiply that, use the OH times the H plus equaling 1 times 10 to the negative 14th to find that. And so if you forgot this equation, H plus times OH minus equals 1 times 10 to the negative 14th. I know the H plus to be 3.16 times 10 to the negative fifth. OH minus is the thing that I want to find, and that would equal 1 times 10 to the negative 14th. Divide both sides by 3.16 e to the negative fifth, and I'll let you do the rest on your calculator right here to get the OH minus concentration.